I'm really happy to be here. This is my favorite organization. And I think it's an organization with tremendous power, some of which is already felt around the state, but there's more potential, and I'm going to be cajoling you to be thinking about how some of the messages that we are trying so hard to communicate more broadly, we can do that more effectively. And I'm thinking more and more about impact in terms of, as a researcher, I'm just finding that I write research publications and they don't have much influence on people's behaviors. But we have a lot of skills in the room and in the society, and marshaling that energy and that capacity, I think, is a high priority. What I want to do this morning is talk about change or transitions, which is the theme of this conference, so appropriate that I would focus on transitions. And as Jean mentioned, the primary transition that I want to focus on is related to sea level rise, which we can see out the back door of this lovely facility. But I also want to step back and talk about other transitions, mostly focused on coastal systems. I do this with increasing alarm as the evidence accumulates. But I sometimes feel like the knight in Monty Python who, despite some injuries, kept fighting. No. Okay, so transitions. The biggest and most rapid transitions in coastal Florida are related to development, obviously. But what I want to focus on today is transitions in the more natural parts of the state, which we're fortunate enough to have. And I don't want to focus solely on sea level rise, as I said, because there are other transitions that are happening, other rapid changes that are all interrelated in super interesting ways, I think. And I want to build a case for the complexity of these interactions. And we've certainly seen the effects of pollution effects in our springs and near-shore waters, climate change related to sea level rise, spread of tropical diseases in Florida, massive habitat loss, and please do sign the petition. That toll road proposal is just dreadful. And invasive species that will come up and with which many of you deal on an almost daily basis, if not daily. So that's going to get worse. Sorry, but human populations are growing rapidly. Water use is increasing exponentially as well. Water use per capita and just more people. And in Florida, we're amongst the worst in terms of water use, and not enough is being done about that. The way the laws are set up, it's really hard to change some practices, but others can be changed. But this is the kind of change in behavior that's really hard to make happen. Energy consumption is going up, and a lot of that is fossil fuel energy. Gratefully, there's an increase in renewable energy, but energy consumption is going up, which is going to be a problem. The eating lower on the food chain is getting to be increasingly important, especially with beef, for which we know the energetic costs of beef and the water costs of beef are just outrageous. And globally, as people increase in access to resources, they're using those resources, and they're eating more meat, and that's causing all kinds of problems related to all those other problems that I mentioned before. The plastics epidemic is just mind-blowing, and doesn't seem to be slowing down. We're doing what we can, nibbling away at this little by little with disposable straws and what have you, but this is part of culture that's difficult to change. And now it's estimated that the mass of plastic in the world's oceans is about the same as the mass of fish in the world's oceans. And this, we just need to deal with this problem. Dealing with problems is a lot harder than pointing them out and explaining them. This is one in which a lot of us are involved, the fertilizer use that is increasing substantially, exponentially around the world. does lead to increasing agricultural productivity, but the focus of many of us is the use of fertilizer on turf, exotic turf grass lawns. Turf is now the #1 irrigated crop in the US. It's the #1 irrigated crop in Florida. So Florida agriculture and the IFAS of my university point out that they grow the food for the world, but they also grow the turf for much of the Southeast, and nobody eats turf. In fact, you better not, because it's probably toxic. So we're seeing these effects with springs. We'll hear more about that today, but these red tide episodes are increasing in frequency and intensity, and that has to do with these other problems, fertilizer and warmer water and so forth. And so this is something that's close to the heart, and I'm surprised there's such a pushback when county by county we try to pass fertilizer ordinances to restrict just seasonal use of fertilizers on lawns, and the pushback is organized. There's a whole bunch of scientists that are supporting the fertilizer industry and the turfgrass industry, and it takes a great deal of effort to get a fertilizer ordinance passed. What we should be doing is getting lawns stopped, or at least chem lawns stopped, in favor of diversity. Red tide, I don't have to say anything about that from people who live down this way. It's been terrible. International travel is increasing exponentially, and I contribute to this, and many of you do too. But along with international travel and all this interconnectedness, we're getting an increasing rate of introduction of exotic invasive species. And I'm going to come back to this one later on, because I think it's associated with the loss of coastal forests, on which I'll focus much of my attention this morning. Also getting warmer, and the frequency of freezes in this latitude is decreasing. Frequency of anomalous hot spells, what is it, 5 out of the last 6 hottest years on record were in the last 10 years, and it's whatever. It's just not getting better, and it's unlikely to, that situation is unlikely to change, because in order to change it, individual people have to make sacrifices or changes in their behavior that don't benefit them directly, benefit society at large over the long term. And it's really hard to get people to do things that are not in their own short-term vested self-interest. And so this is not going to go away. And that's why the focus on both mitigation and adaptation, which I'll get back to in a minute. So these problems of disease and habitat loss, and today is National Endangered Species Day, and the rate of species extinction is also accelerating, and all underlain by increasing human population, as well as by increasing per capita consumption of those humans. And those are related, as you can see. I haven't even drawn all the arrows between population and water use and pollution and fossil fuels and sea level rise and all those other factors. So this is a nested set of issues that are connected in non-linear ways, which makes it very hard to understand overall. But what we do know, and what we can see looking out the back door of the hotel, is that the sea is rising. That global rate of 3.2 millimeters per year, that's about the thickness of a pane of glass. Doesn't seem like very much, but one of the things to keep in mind is that the surges of storm surges associated with sea level are exacerbated way more than you would expect from the actual rate of sea level rise. So a small change in sea level leads to a great increase in the distance that sea surges storm surges penetrate landward partially because of reduced friction. I'm sure conjuring up in your mind all of the things that we need to do to deal with this, to adapt to this. Coastal vegetation protection being primary among those interventions. And what we're seeing and what we can see is that the transitions along the coast are happening at a really alarming rate, and they're really quite evident. So this is a photograph I took from a helicopter flying over Waukesasa Bay just north of here. And what you're seeing is cabbage palms that are looking a little chlorotic or dead, and mostly red cedar, dark green in the top, and then fading out and dying. And this is a scene that you can see all the way up and down this coast. But I want to build a case for having some destinations, and one in particular, where you can see the effects of sea level rise. But I should step back and point out that there's a scientist standing up here who spent his career collecting data and analyzing data and making information available, which I have seen as my job, was to provide the public and policymakers with the information. Communicating it to those policymakers and the public is a challenge. That's why organizations like this are important, I think, as intermediaries between the scientific community and the public, the informed public. But my job was getting information to the policymakers and the public, because then behavioral change would happen. So this information deficit hypothesis probably should be called a myth, because people don't change their behavior in response to information, or they seldom do. And I don't know how to deal with this, because I've spent my career providing information. And now I'm realizing it's not enough. One of the things that is abundantly clear is that the messenger matters. So I'm increasingly sensitive to who it is that's communicating the information and how much more effective it can be if the right messenger delivers the information. And for me, the best example is climate change, and the spokesperson being Al Gore, and the consequences of that, which are not direct and not absolutely clear and certainly debatable, but what if he was the spokesperson for climate change? There are a couple of you who don't recognize Garth Brooks. But it would have made a big difference. It wouldn't have become a liberal agenda, perhaps. But even if Garth Brooks came out in support of mitigation of climate change, it would be a problem, because people would have to change their behaviors in ways that don't benefit them personally over the short term. Okay. Information is my business, and I'm trying to transition into impact being my business, but yesterday we were out in the marsh. It was north by Yankeetown. It was a glorious day. The wind was blowing. It wasn't too hot. There was nothing biting. I mean, I hope you don't think that's the way it is out there all the time. But we really had it good. And what we were doing was looking at transitions. And the big transitions that we were looking at were between coastal hammocks or coastal forests and salt marsh. Sometimes, we didn't see this, but on other places along the coast, you have coastal hammock transitioning directly into mangrove forest. Within the salt marsh, we talked a lot and looked at transitions between domination by salt marsh cordgrass and black needle rush, and what's driving this. And then this big and rapid transition right at this latitude anyway, where salt marsh is transitioning into mangrove forest. But there's a back transition that's happened before, at least it happened back in 85, I think it was, when there was a hard freeze and the mangrove forest gave rise to, or it returned to salt marsh. So we were studying these and looking at these transitions out there and talking a lot about salt, because these transitions are driven primarily by salt. And thanks to the work of Kim Williams and a whole bunch of other researchers, faculty, students, and so forth, we've been able to assemble a list, a ranking of sensitivities to salinity from the maples and ashes that drop out when salinities rise just a little bit above freshwater, all the way down to red cedar and cabbage palm, which are our most salt-tolerant upland species. The mangroves are down here. Black mangrove can take 70 parts per thousand. I should say seawater in the Atlantic is about 35 parts per thousand. In the Gulf, maybe 30. Near shore, because of the Swanee, maybe 15 or 18. It varies, but it gets more complicated than that, which I'll show in just a minute. Brazilian pepper, which I mentioned before, is problematic because it's among the more salt tolerant. It's not as salt tolerant as the mangroves, but it's more tolerant than the coastal hammock tree species, and competes with them for water. So it's evaporating water, transpiring water, and concentrating salt in the soil. So, but what we have is huge areas of dead forest. I'm going to start out with this cabbage palm, which was how I got involved in this in the beginning. Because in the early 90s, I got a call from a physician who owned what's now Withlacoochee Gulf Preserve, which I want to advertise. It's a great place. It's just up the road, run by the city of Yankeetown. Very worthwhile destination. He called and said his palms were dying. And I remember lethal yellowing from the 70s, and I was really alarmed. Now I'm alarmed about the new mycoplasm, about which nothing is being done. But so disease, what's going on? So we came down, a group of us, and looked at what was going on, and a plant pathologist was along, and he, of course, found lots of pathogens, lots of fungal pathogens, for example, on the cabbage palms. But then as we looked, we saw, wow, it's not only cabbage palms that are dying, also red cedars are dying. Red cedars, a gymnosperm, unlikely that the same pathogen is going to kill both palms and cedars, so we stepped back and went up in a helicopter and started a long series of research projects on which much of which talking now is based. So we did find pathogens, but it didn't seem to be what was going on in terms of the death of the palms and the other trees. But it got more complicated because the small plants were dying before the big plants, or regeneration was failing. But then when you start talking about regeneration, it's not just water and salt and sun. There are other species involved, including one of my favorites, which is this beetle, which is a species-specific seed predator. Lays its eggs on the fruits. You can see the little white dots on the outside of the cabbage palm fruits, and burrows in, and the larvae lives inside the fruit. I had one born in my hand. It was really a warm moment. And it emerged, yeah. It was with me for quite a while. But they're playing a role out there. But wait, this whole coast is not a wild area. It's wild now, but it has been influenced by humans. Just north of us is Cedar Key, where the Faber pencil slat factory called for the harvest of thousands of red cedar trees every month. And the Donex broom and brush factory making clothes brushes. When my father had a woolen suit that he would brush off every morning before he'd go to work, and it was made from cabbage palm fibers that come from the end of the trunk, so you cut the tree down to get the fibers out. So that influence is going to be long-lasting on trees that live several hundred years. And then there's this Brazilian pepper that comes in and transpires tremendously, takes water from the soil, leaves the salt behind, and concentrates it. So this biotic interaction is also influential in this transition of coastal forest to salt marsh. And then there are dispersal agents. There's really no reason at all to have this picture here because it's a raccoon eating Christmas berry, but I couldn't resist, sorry. So we go back to this model, and we're thinking also not only about this transition from coastal hammock to salt marsh, but transitions within the salt marsh and between salt marsh and mangrove. And within the salt marsh, whether salt marsh cordgrass or black needle rush dominates seems to be controlled pretty much by this beast, a marsh periwinkle, a snail that, if in high densities, can mow down an area of Spartina cordgrass and make it more accessible to both mangroves and black needle rush. But it's not only periwinkles that eat salt marsh cordgrass, there are also marsh rabbits that hide under the black needle rush where they can't get grabbed by hawks and owls and race out and eat Spartina and run back in, and you can see the lines of rabbit pellets on the edge of the black needle rush. So they're important. I still haven't seen a marsh rabbit jump in the water and swim away, but that's apparently how they escape from alligators? How do you swim away? I don't understand this, but I am a botanist, so. The populations of those snails are controlled by a whole bunch of different species that eat them, including blue crabs, which we eat, and red drum, which we also eat, and terrapin, which unfortunately are killed in nets and drowned, that hopefully terrapin populations are recovering. So whether there's a lot of salt marsh cordgrass depends a lot on whether there are a lot of these predators, which our populations are controlled in part by humans and crabbing and fishing and netting and so forth. So it gets to be a little bit more complicated than just salt and water and sun. And then these mangroves at this latitude are coming in like gangbusters, both red and black mangrove, very different species, both of which are viviparous. They give birth to live young, which is rare in the plant kingdom but common in mangroves. So the seed germinates on the tree, so this propagule floats around. Where it floats to it varies with the density of the vegetation and storm surges and so forth, but the trees start to reproduce when they're only 3 years old. Some of you are seeing this happen where you live, right outside on the coast here. It's happening right now. So salt marshes are being converted into mangroves, both the black mangrove that exudes salt on the leaf surface, and red maple, a red mangrove, which filters out salt from the soil, but also has these viviparous seedlings that germinate on the tree and float around, and then overtop salt marsh. And I don't understand why down around Tampa there's any salt marsh left. Why hasn't it all turned into mangroves? And there are some normative issues here too about people like salt marsh, and should we do anything? This discussion came up yesterday. Should we do anything about the mangroves, or so that's an interesting process, but a societal decision. And this beast, which is a sesarmid crab, is very much influencing the rate at which mangroves are taking over salt marsh, because it's an omnivore but loves to chew on the propagules of mangroves and the small seedlings, so it kills them. And if these crabs, these sesarmid tree crabs, mangrove crabs, are abundant, then this transition, which is what I'm talking about, is going to be slowed. So this is what our model ends up looking like. And I was rather disappointed with the group yesterday. I was hoping for some clarity emerging, but obviously, there's, yeah, it's not simple. In fact, it's not simple at all. Simple is when you have known knowns. And this is the arrogance or the hubris of scientists, that we sometimes think that we know what's going on and we can predict what's going on. And then we're willing to admit that it's pretty complicated, so we have to do more research and understand more. But what we're actually dealing with is complex systems that include a little bit of this chaos that makes change, transitions, the details of those changes unpredictable. You can learn as much as you want, but you're never going to be able to nail it. Is this forest going to be converted into a mangrove in 10 years or 5 years or 2 years? You can't get there because of these multiple nonlinear relationships that are interacting and leading to those chaotic phenomena. Oh, plus there are also these historical legacies that I mentioned before, that the harvesting of cabbage palms and red cedar, there are legacies of that are still influencing what's going on out there. Fire suppression has been an issue. The marshes used to burn, and they're not allowed to burn anymore, or nobody's burning them. And the mangrove, the salt marsh to mangrove transition might be very different if there were regular fires. What this means is that surprises are going to happen. And this is what creates humility among restorationists when you're out there restoring pine savanna or wetlands or something, and all of a sudden something happens you didn't predict at all. You realize that you don't understand it all, and maybe it's not all understandable, but you just keep working at it. And then the big part about transitions is that they don't happen smoothly. The sea level doesn't rise continuously at the same rate. Those are long-term averages. The change from salt marsh to mangrove doesn't happen in a steady fashion. There are thresholds or tipping points or periods of rapid transition that are that we need to grapple with. And the way we think about this in the scientific community is in terms of resilience, which is getting to be a pretty familiar concept, but just to make sure we're thinking about it the same way, you can think of resilience as a surface with different states in which an ecosystem can be. And the ecosystem gets perturbed by disturbances or stresses, but if the system is resilient, it returns to where it was. So the storm comes in, knocks down a bunch of trees in a coastal forest, but it comes back to coastal forest. A coastal forest burns, but it recovers to coastal forest. But coastal forest doesn't seem to be as resilient as salt marsh. And salt marsh seems to put up with a lot more abuse, disturbances than like snail grazing, than a coastal hammock. But on the other hand, if you have mangrove invasion, then the salt marsh state can transition into another of mangrove forest, pass this threshold and go into another basin of attraction that would be another ecosystem. So this is the model that many of us have in our minds, which again inspires humility, because predicting these when an ecosystem is going to cross a threshold is very difficult, other than in retrospect. Oh, we passed a threshold. But that's not very helpful. And we have passed thresholds, and we're passing them every day or every year or with every storm surge. And here is, I'm going to make a case that this is the best place in the world to see this. Here we are on the Big Bend coast of Florida, the least developed coastline in the lower 48 states. We are here in that black patch. And very little development, which means that you don't have to worry about saltwater or freshwater withdrawal from the aquifer leading to saltwater intrusion, because there's very little water being taken. So I want a place where I can show people the effects of sea level rise without it getting complicated by something like saltwater intrusion from overpumping from the aquifer, which is happening in a lot of Florida, unfortunately. This up by Yankeetown, State or County Road 40, which crosses 19 in Inglis and goes out to the coast, runs just north of the Withlacoochee River. All along here is a fabulous place to see the effects of sea level rise. Well, Florida is a good place to see the effects of sea level rise because we're so flat and the elevations are so low. This area in particular is good to see the effects of sea level rise because unlike the Louisiana, the Mississippi Delta area where there's a great deal of subsidence, here the coastal ecosystems develop on limestone platform. So the people on the trip yesterday, a couple of them ended up pretty muddy. They must have gone out of their way because the mud wasn't all that deep. But getting muddy is fun anyway. But when you're out there walking in the marshes, you're walking on rock a lot of the time, or rock close below the surface. So we're not getting subsidence of the land due to overpumping of water or organic matter settling or anything else. So that makes it so the signal to noise ratio of the signal of sea level rise is not obscured by the noise of other phenomena. Like, for example, Atlantic, or heaven forbid, Pacific tides, which are way bigger than the tides here. Tidal fluxes around here are in the 1 foot to 2 foot range. The Atlantic is double that, and the Pacific can be quadruple that. So the signal of sea level rise is obscured by large fluctuations, tidal fluctuations. But this is a low energy coast, which makes it a good place to separate the signal of sea level rise from the noise of tidal fluxes. And we also have historical imagery that documents the change that you can see on the ground. So here we have 4 historical photographs. Draw your attention to 1944 and Forested Island B. So this is a patch of cabbage palms and red cedars surrounded by black needle rush and salt marsh cordgrass. By 1999, it's gone. And many of you know of other places in Florida where the same phenomenon has happened. And there, between 1974 and 1991, we had a split that got one island became 2 islands. One island became one island with a channel between 2 very distinctive islands of forest. So this is happening in almost real time. And it's also this particular place on County Road 40 is great because to see this effect, because it serves as a dam that keeps the floodwaters of the Withlacoochee River from washing away the salt to the north of the road. There's one culvert under County Road 40. And so all along its length, the waters of the Withlacoochee are kept from proceeding further north. I mean, this Google Earth image, this is south of the road. There's the Withlacoochee River. This is high forest, diverse, 10, 15 tree species. Right next to the road. You can walk off the road and walk into this forest. North of the road are these patches of standing forest or islands of forest in a sea of salt marsh, but they're also patches of dead trees, the ghost islands, they were calling them yesterday. There are some moribund islands too, where the trees are obviously dying. But this is a salt washing effect from the Withlacoochee. And there it is, thanks Gene for this picture, looking out of the road, coming back from the coast, south of the road, high forest, and sawgrass. North of the road, black needle rush and spartina, salt marsh, and patches of forest that aren't looking very good. Okay, so my challenge is to, and the challenge I want to put before you is to think about how we can use this experience that you just got, either the people who went on the trip yesterday or people who have been out there before, and the people listening today, how can we use this experience to inform people, to engage them emotionally, to get over the hump of denial of sea level rise? Because it's really hard to deny it when you're out there and you're seeing the dead trees. And if you venture off the road into the salt marsh, be careful you don't trip over a stump, because all that salt marsh was forest a decade, 2 decades, 5 decades ago, and many of the stumps are still there. So my approach would be non-judgmental, not saying, you know, you should be on a bicycle and not in a car. You shouldn't be eating, you know, a beef sandwich for lunch, but rather, this is it. Look, it's happening right before your eyes. But what sort of information do we provide? Do we provide historical photographs, or I want to engage painters in painting scenes of what it was like 50 years ago, what it's going to be like in the future. I was thinking of a billboard. I hate billboards, but a billboard with an opening in the middle that allowed you to see the landscape, a painting above of what that landscape looked like 50 years ago, and a painting below of what it would look like 50 years in the future. And they can all be beautiful, but radically different. And I am a technophobe, but the likes of Valerie and others, maybe we should make this into a virtual reality. Can you do that? You know, a headset, and you just kind of can touch, and we could have surround sound and smells and all that. We could get biting, some kind of things to bite people. I don't know how to do it, but we need to do it, and a lot of you have the skills needed to make that happen. I think this is perfect for citizen science, getting school groups out there, putting in plots and monitoring and providing them with the data, incorporating this into the coastal school system curriculum. We got to get over the hump of getting people out. Apparently school buses are the problem of transportation. God, can't we solve that? Somehow. And I'll even lend anyone who wants it my tree bicycle, which is really fun for pedaling up cabbage palm trees. This is how we measure growth rates of cabbage palms, by marking the leaves. So I want people to be able to see this landscape and run the movie forwards and backwards, imagining this was all forested, that it's all going to be seafloor in the future, and have some idea of how long that's going to take, because it's not that long. Take young people out there. When they're my age, this will be underwater. Okay, just a minute on something that I'm learning about recently. A lot of us are involved in trying to get away from the chem-lawn approach to landscaping, but recent studies have shown that a tremendous effect of storm surges on pollution. And what's worrying me, what I think we need to make people aware of, is the fact when urban and suburban landscapes are flooded in storm surges or with high intensity rains, when the water drains out, the water is a toxic cocktail of everything that's been applied to lawns and elsewhere. Heavy metals and hydrocarbons and some of these estrogen mimicking pesticides that are legally used on lawns by professional lawn care companies. Okay, sorry. But seeing this should cause us to shout. We should be yelling at people, I think, or we should be pleading with them, or we should be protesting this. All of that ends up in the water that drains from our landscapes. And it drains from our landscapes at increasing rates because of storm surges, but also because of increasing intensity of rain that exceeds the infiltration capacity of even our sandy soils. So all of these end up going into the water. And this is just one of the consistent predictions of all climate change models, is that rainfall intensity will increase. This is from the US National Climate Report that came out on Black Friday, trying to suppress it, but didn't work. we found it, and high-intensity rainfalls that greatly exceed infiltration capacities are getting increasingly frequent. So we need to care about this. So no one should be proud of this. This should be something an anathema, something that's prohibited. And this in particular galls me, because if there's a group of organisms that suffers from what we do to lawns, it's the amphibians, and they're not smiling, they're dying. So this is outrageous. And I know that agriculture and golf courses, for some reason, are exempt from a lot of regulations, but this is evil. I'm a scientist, I'm objective. Is evil is, that's a scientific term? No, maybe not. But maybe we should have little signs that we put up that, your lawn kills my fish, or something like that. And we've been at this for a while, trying to understand these processes and wrestling with all these connections. But here's something that's very local and very possible. This is part of adaptation and mitigation to change, not just climate change, but all kinds of change. Adaptation is the reduction of consequences of change. Mitigation is reducing change. We need to do both. But there are many of these interventions that are in between. So non-toxic landscapes would be a way of mitigating change, but also adapting to change. Maintaining biological diversity can both mitigate the effect of change and allow us to better adapt to it. I made this slide before I talked to an expert on what's happening along our coast. I have relocation there. He said, Americans don't retreat. Okay, so we need to take that into account. But all of these things, vegetation buffers and so forth, are part of the approach that we need to be advocating, and we're doing it. I mean, maybe not enough. There's still a lot of lawns going in. And one of the claims of the supporters of the toll road is if the toll road goes in, it will promote development and will promote lawns, and it'd be great for industry and employment and but there are efforts that are underway. In Alachua County, we have this swap program. If you want to get rid of some of your turf and plant natives, you get support from the county, which is just great. And of course, the Native Plant Society has been at this for a long time. We need to up the antes. We need to speed this up because there are too many homeowners associations that require turf grass. There's just too much turf. The question for all of us, what else can we do? And what more can we do? And how do we marshal our skills to really make a difference? Because this is the landscape where I live for which I pine. This is a longleaf pine savanna. This was a Bahia grass pasture. And so this is my success. I had to crop the picture because restoration is really hard. Takes a long time, but we have had some successes. And I think this is what we should be shooting for. And working on it with letters and conversations and policies and so forth. Because diversity is what we should be celebrating. And we are in a new epoch called the Anthropocene or the Homogeocene, and we need to do something about it. And informing people is what I do for a living, but now I'm trying to both inform and entertain, and I don't know what else to do, but I'm looking for suggestions. Thank you.